significant. They are there because we can read to that many decimal places on our measuring device, and we are sure that it was on a line, so we're putting the 0 at the end. What is the difference between 30.0 grams and 3.00 grams in terms of sig figs? I know that 30 is not drink. Nothing. In terms of sig figs, they have the same number. So how does that compare to 0.300 grams in terms of sig figs? Same. All three of these have the same number of sig figs because the zeros are after the decimal and after the number. This 0 was a captured 0, but because this one is significant, the middle has to be.
I was wondering, what if the number was like 3,200 and then it was decimal point 0.0025?
3,200 decimal point 00 what? 25 grams. All significant because they're in the middle. All significant if these were zeros, because these zeros are after decimal and after a number. They're way after, but they're after. So all significant. Okay? Yep.
If you have 0, is it 1 or none?
Not necessarily, but that's a good way to start looking at it. You could have, let's see, what if it was this? Some of those zeros are significant, measured quantity is supposed to be 0, and some are not. Which ones are? The ones in between. So these two zeros are really supposed to be 0 because this is a significant digit. And these are just placeholders. So there are times when it's two rules in one.
Like when you just have like the number 0, though, is it?
Oh, just 0?
Just 0, or like 0.0.
Well, that's not even a measurement, really, is it? That's something that doesn't even show up yet as a measurement. So, okay. Where are we? What number?
28.
Oh, 28. Okay. How many sig figs to use in answers when multiplying and dividing? Okay, multiplication and division are the easiest. That's the Red Rover rule, or my Red Rover example. You round off your answer to match the least number of sig figs in the calculation. Okay? So if you have, say you're multiplying this 300 grams with 1 sig fig times the 30.0 grams with 3 sig figs. What is less, 1 or 3? That was an easy question. 1. So how many sig figs go in your answer? 1. Okay? So if we multiplied a number that we're not really very certain about, because we only have an estimated digit, by 1 we're pretty certain about, because we have 2 certain digits and 1 uncertain digit. This one is less precise, so we have to round off our answer to the least precise. Okay? We can't get really good results for a calculation when some of our initial measurements were not very precise. 29. How to identify a measurement that is written to a specific number of sig figs. So this is going to ask you, how many sig figs are in this number? And you'll see something like this. How many sig figs? What do you got to do is count. I hear 5, I see 3s.
5.
I see lots of answer choices. Okay. Which 5? That's dinosaur. The 10200. These are the significant digits. Those are just placeholders. Okay. What if I asked it this way? How many of the zeros in this measurement are significant?
3.
I guarantee you if I ask that, one of the answer choices is going to be 5. Okay, so watch for that on the question. Is it asking for how many sig figs altogether, or is it asking how many of the zeros are significant? Alrighty. 30 is similar to the example I just mentioned. It will be asking you something about just the zeros. Which measurement has only non-significant zeros? Or which one has only significant zeros? If you know your rules, you're good. Owen, you with us? Okay. 31. Very similar to number 29. You should have no trouble with that. 32. How to add specific numbers and round to the proper number of sig figs. Please remember that when you are adding, we need to look at where the precision is in terms of decimal places. And again, it goes to our least precise measurement. But say we have something measured to the ones place, and we're adding it to something measured to the thousands place, and something else measured to the tenths place. We're going to add all those together. Which of these measurements is the least precise? The first one. So the leftmost uncertain digit here is the 1 in the ones place. If we're only sure about this measurement to the ones place, when we add, even though mathematically we can get more decimals, but we weren't sure here, this is our estimated digit, then we have to round off to the ones place.